Good day, ladies and gentlemen. Now we are focusing on second order differential equations for maths M6. So we'll be looking at again the particular solution. For differential equations are always target particular solutions because once you know how to get a particular solution, indirectly you know how to get a general solution. So for second order differential equations, you have to start with a general solution. So the general solution is given as y equal to yc plus yp. This is what I will call a general solution. So yc is the complementary function and yp is the particular integral. So for me to calculate a particular solution, I must get this general solution first. I must make sure I've calculated my yc and I've calculated my yp, put them together before I start looking at those conditions. So let's start with yc, which is usually the easiest part to handle. So with yc, all we need to do is know that with yc we use the left side of the equation to solve for yc. And that means for the right side we will replace it by 0. So the first thing we do is create a quadratic equation using this. So if I am to create a quadratic equation using the original differential equation, my second derivative, I will call it r squared. If you choose to work with the variable r, so everywhere you see the second derivative, you call it r squared. Then the first derivative, you will call it r, and then your y will be 1. So if it is 1, it means I'm having 9, because if you say y is 1, it's 9 times 1. So I don't expect you to say it's 9 to 1, because 9y means 9 times 1. Then, because we don't use the right hand side for our yc, we'll have to replace it by 0. So this is your first step of a second order differential equation. So once you go through this first step, we expect to see a quadratic equation. So step number 2, you have to solve this quadratic equation. And I'll always advise students that when you meet a quadratic equation, please take your time and use the formula, except you are very good with factorization. So from this, looking at this quadratic equation, I can already see that my r is 3 and the other r is also 3. That is because for me it looks easy to solve, but I will advise that as a student, please substitute it into the quadratic formula and take your time to solve. Because if these answers are wrong, it's a problem, you cannot get your y's. So from what I'm seeing, my y is 3 and my y is 3. The other y is 3, so you must get 2 values of y, because in the quadratic equation, the degree is 2, it means you must get 2 answers. And whenever you solve a quadratic, if you are doubting your answers, just try to resubstitute them into the quadratic and see if you get 0. You see, if I get 3 and put there, 3 squared is 9, 9 plus 9 is 18, and negative 6 times 3 is negative 18. So it's all giving me 0 to show to me that my answers are correct. So these two answers, I'll call it R1 and the other one will be R2. So if you have a good look at R1 and R2, you will see that your R1 is exactly equal to R2. The reason why I'm targeting this is because for me to read my solution for yc, I need to go to page 7 of my formula sheet. I will see some 3 formulas that are talking about R1 being equal to R2, or R1 being equal to R2, or R being complex. Whichever one my solution falls in tells me how to read my solution for yc. So my solution for yc, I will be targeting the one where R1 and R2 are the same. So if I go to that, I will say my yc is equal to, and in my formula sheet to get the correct way to write it. So I'm targeting the solution where R1 and R2 are the same. So I'm supposed to get e to the power r. My r is 3x. So it's e to the power rx. in bracket a plus bx. So that's all about y6. So as an N6 student, guys, I expect everyone to be able to get the complementary function right, which is what we call y6. So all you need to do is 3 simple steps. You create a quadratic equation, solve the quadratic equation, then the way your R's or the solutions of your quadratic are related, you go to page 7 of your formula sheet, you copy the correct option for your solution. So I'm done with my y6, then I can do my yp. So I'm doing my particular integral, which is my yp. So my yp always depends on the kind of function you see on the right hand side. So looking at the function on the right hand side, I can clearly see that that function is a linear function. What makes it linear is not the fact that it has 2 terms, it's the fact that I'm seeing x to the power 1. That is what makes it linear. So I'm covering the 2 just to confirm to you that even if it was just 4x, this would still be linear. So that is a linear function. So when your yp is linear, you must also choose your yp as linear. So I will choose my yp as cx plus t. You see, that's a linear function. So it's very dangerous. The danger here is that whenever the right hand side is linear with 1 term, students are tempted to also choose 1 term, which is very wrong. Even if my right hand side was having only 4x, this is linear, my yp must be chosen like that to have 2 terms all the times. Because what makes it linear is not the 2 terms here, it's the fact that I'm seeing x to the power 1. So when I'm choosing my yp, I must always choose a standard linear function with 2 terms all the time. So that's my yp. So after choosing your yp, you are expected to differentiate it 2 times. So I will do that. I will differentiate my yp for the first time. So if I'm differentiating it for the first time, you know that the derivative, you are only differentiating the value. So if I differentiate, I will get c, since the derivative of t will give me 0. Then that's the first time. I will differentiate again for the second time. So if I differentiate for the second time, I will get 0 because there is no x left. So from this page, the next thing I have to do is to now substitute all the data under yp. When I say all the data, that means yp, its derivative first and second derivative, back into the original equation. So when I go back to the original equation, where I see second derivative, I will capture second derivative of yp, which is 0. Then minus 6, where I see first derivative, I will put first derivative of yp, which is c. Then plus 9, where I see y, I will put my yp, which is cx plus d. Then I equate to the right hand side, which is 2 minus 4x. So this equation should help me to be able to calculate the values of c and d. So to calculate the values of c and d, all I need to do is compare coefficient. So if I'm looking on the left side, coefficient means the numbers in front of x and so on. But before doing that, maybe I can open the bracket to make life a bit easy. So there is 0 there, I'm left with negative 6c plus 9cx plus 9d. So this 9 goes here and goes there, is equal to 2 minus 4x. So I can now compare my coefficients. So if I start with the coefficient of x on the left side of the equation, the coefficient of x is the number in front of x. I see a 9c. On the right, the coefficient of x is negative 4. So if I solve this, I'll get my value of c. So this tells me that my c is negative 4/9. So I'm done with c. So I know if I go back there, I will put a negative 4/9 there. Then we'll do the same thing for the constant. Looking at the constant term on both sides. On the left, the constant is negative 6c plus 19. So I get negative 6c plus 19. On the right, my constant is 2. So that's equal to 2. But now you realize we've got c already. So I'm putting c there. So if I put c there, I get negative 6 into negative 24 over 9 plus 9d is equal to 2. So if you multiply these two, the two negatives now become positive. So with this, I can easily get to my d. So to get d, I have to take 2 minus 24 over 9, because if you look at this, 6 times negative 4 is 24 over 9. We cross that side as negative. So I'm taking 2 minus 24 over 9, 2 minus 24 on 9, that gives me negative 2 over 3. Then I'll divide by 9. Divide by 9 gives me negative 2 over 27. So my d is negative 2 on 27. So I've seen my d. Now that I'm done with c and d, I can now transfer them into their position. So therefore, my particular integral yp is equal to negative 4 over 9x, x here, because it's going there, minus 2 on 27. So up to so far, you realize that we have succeeded to get yc and we have succeeded to get yp. So that means we know the general solution. So therefore, our general solution, we can pull the two together, our yc and our yp, to create our general solution. So we've got e to the power 3x in bracket a plus bx, then minus 4 over 9x minus 2 on 27. So that is our general solution. So if you can check, you'll see that up to so far, we didn't touch the two conditions. These two conditions here, we've not touched them. We only use them when you are doing particular solution. So if this question was saying solve for the general solution, we are obviously going to end it because we have already arrived at the general solution, as long as you can get your yc and your y. So what is left now is for us to calculate the values of a and b. Once you can calculate these two, you come and substitute them there, then you get your particular solution. And since there are two constants, that is why they've given you two conditions for you to create a pair of simultaneous equations. So I'll start with the first condition, which says x is equal to 0 when y is equal to 1. So I'm substituting that into the general solution. So if I get into the general solution, I will replace every y by 1. I've got only one y there, I will replace it by 1. Then I will replace every x by 0. So I will get e to the power 0, since 3 times 0 is 0, into a plus 0, since b times 0 is 0, then minus 0 minus 2 on 27. Minus 0 because 4 over 9 times 0 is 0. So this immediately tells me that I am seeing myself with 1 equal to a, because e to the power 0 is 1, minus 2 on 27. So 2, negative 2 on 27 is a like term to 1, so it must move to the left to make 1. So like terms, like members of the same family, they must stay together. So I get 1 plus 2 on 27. That gives me 29 on 27. So it means that my a is equal to 29 on 27. So I'm done with a. I'm now left with b. So to get b, we need the next condition. The next condition says x is 0 when dy over dx is 3. That's what our next condition is saying. So in this situation, it's not as easy as the first, because with the first we were seeing the equation with y. But we don't have any equation starting with dy over dx. That simply means we have to start by looking for the equation that starts with dy dx. And to get that equation, we have to get back to our general solution and differentiate. looking at our general solution, we have to differentiate it to get y dx. So if I'm differentiating my general solution, now this is where the trouble steps in. If we look at our general solution very well, it's obvious that this general solution starts with a product. That is a product of an exponential function and a linear function. So when we are differentiating a product, there is something called the product rule, which we must use. So it means we must go through that function. We call one item u, the other one as v. Then we use our u v prime plus v u prime, the way we taught in N4 mathematics. So that is what we have to do just to differentiate the first term. We need the product. So we are going to go through that and try to get our product for the first term. So I need my u. U is e to the power 3x. I will multiply that by v prime. V prime means I differentiate the linear function. But this linear function, a is a constant, its derivative is 0. If you differentiate bx, it gives you b. Then plus, I will then take v u prime. My v means I capture a plus bx, then I differentiate e. If I differentiate that exponential, it gives me 3e to the power 3x, then in bracket a plus bx. So up to so far, we have only differentiated the first term, which corresponds to our y's. We still have to differentiate our y. So if we differentiate our yb, since it's a linear function, we just get negative 4 over 9. So that is the derivative, since the derivative of this part is a z. So what does it tell me now? I can now replace the first derivative by 3 every x by z. So if I do that replacement, I will get 3 is equal to e to the power 0 times b plus 3e to the power 0 into a plus 0 minus 4 over 9. I'm saying a plus 0 plus x is 0, so b times 0 is 0. So having a critical look at it, I'll have 3 is equal to b, since e to the power 0 is 1. Another e to the power 0 is 1, so I get plus 3a minus 4 over 9. So that is what I get. So 4 over 9 will move over. Then a, we know it already. So this means I'm having 3 is equal to b plus 3 into my a is 29 over 27 minus 4 over 9. So this is enough information for us to get b. So to get b, I need to take 3, then I add 4 over 9 to it since it will cross, then I'll subtract 29 over 9 since 3 goes into 27 9 times. So I'll try that to see if I can get to my b. So to get b, I'll get 3 plus 4 on 9, then minus 29 on 9. Since I've said 3 will simplify 27 to give me a 9, so 4 over 9 will go there as positive to add to 3, then minus 29 over 9, so that gives me b as 2 over 9. So my b is 2 over 9. So now that I know a and I know b, I can now write my particular solution by just copying the general solution, changing a to 29 over 27, b to 2 over 9. So that's how simple it is. So my particular solution is e to the power 3x, in bracket, our a is 29 on 27, then plus b, which is 2 on 9x, then minus 4 on 9x, minus 2 on 27. So I'm just copying my general solution. Then in the position of a and b, I'm slotting their values in. So guys, that is how we get a particular solution for second order differential equation. Thank you very much.